The difference between open source and commercial is most of the time support. So most of these open source solutions have all the functionalities of commercial ones, like unified log management. You can get everything in just one place, in one big database. You can have scalability. You can do it for a really small company with just a couple of servers, or for big companies with thousands of servers or endpoints. You can have correlation, and in some cases, if you're really into it, you can also introduce machine learning with it. High availability with redundant clusters, and also vulnerability management or ticketing, stuff that will take your solution more into a security operations center zone. Why do I say it's never entirely free? Because it costs you a lot of time to put the effort into building a solution like this. And as we all know, time is never free. Components of a SIEM are plentiful. You need to take into consideration log sources, which are all endpoints and servers in the network. You need to take into consideration parsing of logs and storing them in order to keep them safe from intruders, because if you don't keep the logs safe, then somebody can have access to the information of all your network in just one place. Alerting is just a way of querying the database and finding things that are wrong. Threat intel, which means correlating what you have in the network with data feeds from internet with known vulnerabilities, known attacks, or other indicators of compromise. Ticketing, if you have a bigger team and want to work with, let's say, operations team or people on the field. Vulnerability scanning and vulnerability management. All of these software pieces have open source variants and also paid ones. So even if you want to do it for a small company or just for yourself in a lab, you can do it. But if you go big, you probably need support and somebody to talk to in order to get I don't know, courses, classes to learn stuff, and support for implementation. And most of these also have paid support. We'll take each of the parts of it and go into depth. For log sources, we have beats as the main component. As I talked the previous slide, we think Elasticsearch and the Elastic Stack is one of the best frameworks for doing such an endeavor. So beats are endpoint agents that get installed on endpoints or on servers and get data and push it to the database. We have file beats, which get data from files. We have winlog beats, which get data from Windows events for Windows servers or Windows endpoints. Packet beats that do traffic dumps and listen on network interfaces. We have audit beats, which can monitor folders, for example. If you have an app that is in production, you can monitor the folder that holds the app and see whenever something new appears there, whether it's a pull from the developers or it's some code injected there, you can see the modifications and raise an alert based on that. There are also metric beats, which monitor the machine metrics, like CPU usage, memory usage, and this can be useful in finding malware that is, for example, in memory malware, finding anomalies in the metrics. Also, very important, having some IDS data like Snort or Suricata, which have both open source alert lists and also paid ones. And OSSec is an endpoint agent that monitors for malware. Going further, we have the data now. We have to parse it in order to put it in the database. We can use for that Logstash, which is a very powerful tool and that supports advanced pipelines. It can get your data from all the sources. It can get it from beats or just from SNMP feeds, and put it on a common format that will get stored in the database and make it easier for you to visualize it. It's very important at this step to do a normalization of the data in order to have it all in a easy viewable format. And for this you can use the Elastic Common schema, which is currently in beta, but it's very close to production, and it includes the most common fields. You can you have predefined fields for all logs from Linux, Windows, and the most common applications. All you have to do is run them and go put them through Logstash and then into the database, and it will get mapped to their fields, and then you can go and make your own visualizations, as I'll show you in a later step. For appliances and special logs, you can use grok filtering, which is a tool built by Elastic in order to parse. It's some sort of a regular expressions format, and it helps you parse any kind of log and put it on the common schema. A very interesting thing about Logstash and Beats is that they both have queuing mechanism inside of them. This way you don't have to add another layer of protection in between. If any of the endpoints goes down, or if Logstash or the database goes down, they're inside in-memory queue or persistent queues, and they'll hold as much as you want them to hold. I've tested it with gigabytes of data, and they held them and then pushed them to the database when it was up and running again. Now the database. The database in our case would be Elasticsearch, which is a very versatile search engine, actually it's called. It's scalable, it has high availability built in. It's written in Java, and even though it requires a lot of RAM, it can be installed and run on a 2 gig of RAM machine. So if you want to test it and build an environment like this, you can do it on a virtual machine without a problem. Unfortunately, there are two versions, the open source one and the XPack one. The open source one doesn't have security built in and other interesting functionalities like machine learning or graphs, but some of them you can do with open source alternatives like SearchGuard, which is a very good security tool for Elasticsearch security add-on. It adds users, accounts, and secure traffic. When you start, it's always better to start with at least 3 nodes, because this way you'll have high availability from the start, and it's really easy to configure them to talk to each other, and whenever one of them goes down for updating, for example, the other ones will be still up, and they will synchronize as soon as they're all online. Analysis and visualization. For this, Kibana is used. There is a nice demo of Kibana online if you want to take a look at the power of the whole infrastructure. demo.elastic.co/app/Kibana. There are lots of data there. The very good thing about this is that besides discovery mode, where you can see the logs and go through each event, and you can do analysis on them, and forensic analysis, for example, after an incident. You have the visualizations and the dashboards, which are not only cool for us, but are very nice for management, because they always want to see nice pie charts. Also very interesting is that as long as you have all the data in one place, you can do lots of business use cases on that. You don't only need to do security. You can, for example, if you have a web server and you have a website, you can do all types of analytics like you would do with Google Analytics. Or if you have another app that cannot be run through an analytics app, you can see dashboards here with usage. You can see also availability on the operations side for network and everything regarding availability. Going further, the alerting part. For alerting, a nice tool is 411, which is a tool built by Etsy, a very big marketplace for manufacturers. It's got a nice interface, and the thing that it does is it runs queries on the database in order to find anomalies, and you can set up searches here, searches that are being run on the database as often as you need them to. The good thing about 411 is that it's written in PHP. It's very easy to configure and to add plugins to it. It can be easily customizable, and it can alert you via email or Slack whenever something happens. It also stores all the data it generates also in Elasticsearch, so you can do dashboards with the alerts as well and reporting on that. It has reporting built inside of it, but it's very primitive. It only has active alerts and closed alerts, but it also has interesting incident management option. You can add comments to the alerts and close them with resolutions. This is very foggy, but here you would be able to see this is the panel where you can create searches. You can just add the query in for Elasticsearch. Say what you wanna search for, and add information like how often you want the search to be executed, like every minute or so, and time range for the query. It can alert you if there are specific fields in the database, if there are no fields present regarding that query, or can just count them and see if they reach a certain threshold. Threat intel. For this, MindMeld is a very interesting tool. It correlates all threat intel feeds. You can add, it comes by default with some open source feeds. It's been developed by Palo Alto Networks, and it's open source on their website. You can install it and have access to open source feeds out of the box, and you can synchronize it with Elasticsearch, so you have all the data in one place. Afterwards, for each event that comes into the database, it can be synced to the threat intel, and you can see if it's something of interest, if it's something that that somebody else found before you. For example, file names or URLs. Sources for the threat intel include Alien Vault, OTX, Spamhaus, and various other free sources. These are the optional steps, which are ticketing, for example. This is a very nice but also very frustrating tool. It's called Request Tracker. I see somebody in the back there that has a lot of experience with it and a lot of mixed feelings about it. Anyway, you can integrate it with the rest of the infrastructure so that tickets get created automatically whenever a new alert is raised, and then you can send it to whoever is in charge. The only downside that I see to this tool is that it's written in Perl, so it adds to the overhead of knowledge that you need to have in order to set up all this infrastructure. I'm curious, does anybody here know of a ticketing app built with PHP? Like a serious? Nope? No, me neither. Yeah. Okay. Facebook? Yeah, that would be cool. I don't think Facebook is written entirely in PHP anymore, but I know it started there anyway. Vulnerability scanning. Obviously, everybody knows about Greenbone and the OpenVAS. It's an open source vulnerability scanner. It's not perfect, but it works, and it gives you reports on the assets in your network. It can export CSV, XML, or PDF reports, which can then be synchronized with your vulnerability management app. And vulnerability management. For vulnerability management, I found this tool, this open source tool, that is still under development, but it looks pretty promising, and I think it works. It's worth taking a look at it. Archery, it's called. It's vulnerability management software designed to keep the scans all in one place and designed to give you an overview of whatever is in your network. It can be integrated with also with network scanners, but with application scanners as well. So you can see everything in one place, even if you use Nessus for one part of the infrastructure, OpenVAS for another, or I don't know, Akunetics for your web apps. As I said, it's still in development, but it's under intensive development with commits almost every day. This was my presentation. If you have any questions regarding this whole infrastructure.
So for any questions, here's a microphone.
Yeah, first question. So the thing is that at the beginning you said that one of the steps in order to create your SIEM is to cluster the data. But for instance, if you are getting only the network information from your, I don't know, personal router at home or something like that, how would you clusterize the data inside? I mean, what would be the main categories to be translated in?
Oh, you mean the common fields, or I was talking about. Yeah. I don't know if it's on the.
Yep.
Nope, it's not here. I was talking about the elastic common schema. That's a set of fields that come into the database, and all the logs get. It's like a table header, if you want.
Okay.
And I think it's important to have everything under the same header, the same columns, so that when you do visualizations, you can have a visualization based on source, or you can do pie charts or stuff like that. And including the home router, if it generates logs, it would probably generate I don't know, a CSV that has a table header.
Okay.
Thank you.
Hi. So I have a comment about this. Elk is nice to start a SIEM with, but I think it's missing one important part, the correlation engine, because you have to do like a lot of development work.
Yes, 4.1.1. I was talking about this.
I don't have experience with that, but I'm curious, how competent is it? I mean, does it do moving averages? Does it do? You have to move from moving averages, moving windows. You have to move from atomic events, from single events, to something more actionable. So.
Well, if you can write a query for it in Elasticsearch, you can put it here.
Debatable, but yeah.
Yeah.
Thanks.
No problem.
How many agents do you use from this solution?
Out of the ones that
you speak a lot of bits agents, for example.
All of them.
Do you use one agent or all these agents?
For each.
Collect information.
Well, it depends.
Collect information.
Yes.
And for this, you need agents.
Yes. Well,
how many agents do you use?
It depends on the one for each host, basically.
Okay.
But it depends on the host and the scope of the host.
Hey, so my question is, what's your approach towards monitoring containers, if you have one?
Well, it depends. Most of the containers can generate logs, and they can generate logs outside of the container on the host. So you can grab those logs and parse them.
Are there any other questions? Okay.
Okay, thank you then.
So if there aren't any other questions, thank you, Cătălin.
Thank you very much.
We'll take a small break, and then we'll come back with the second talk. Thank you. Yeah, there are stickers here in the back, so feel free to take some. Okay, so let's get back to business. I'd like to remind you that we have each Saturday we have meeting that we call JMP OX Coffee, where we are trying to teach students and people that are still in school about CTFs, about security, and everyone is welcome there. And besides that, you're also welcome if you want to be if you'd like to hold a workshop. We would be very thankful. So each Saturday we'll be meeting at the Orange Educational Program location, and we thank Orange Fab for supporting this event. And each week when we meet, we have pizza. Thanks a lot, Orange Fab. Okay, so continuing with our second talk, we have here Radu-Emanuel Chișcariu. He's a security researcher at Keysight, and Radu will talk about American Fuzzy Lop. Radu, you have.
Thank you very much for the introduction. Good evening, everyone. My name is Chișcariu Radu-Emanuel, and I'm a security researcher at Keysight. And tonight I'm going to talk about one of my fuzzing projects, and more exactly about how I have found my first vulnerabilities this year. So first I want to ask everyone in the room if you ever heard about fuzzing. Please raise your hand. Please don't be shy. Okay. Okay. So a lot of you guys heard about fuzzing, but who of you actually tried to fuzz something, for example, an application or? Okay, cool. So this is the place to be. So fuzzing, it's about throwing, let's call it pseudo-random, if there are cryptographers around here, input at applications and see how the application behaves. It is a very useful tool, both for the developer and for the security researcher and for the black hat, for the hacker, because if the first one prays not to obtain anything with the fuzzing, not a corner case or a bug or actual vulnerability, then the attacker preys on that. He wants as many bugs and vulnerabilities and crashes as possible from fuzzing. What is cool, another thing that is cool about fuzzing is that the current state-of-the-art software that do fuzzing are very complex, and they do a lot of cool stuff, which we are going to talk about. Also, the interesting thing about fuzzing is that its results are, let's say, neglected by management, and by that I mean if you find something in a library that your project employs, then it won't be a very interesting thing. You will be asked to continue something else with a lot of importance, and that's how events like Equifax breaches happen. Before going into the actual fuzzing, it's important to make some distinctions. There are different strategies, way to conduct fuzzing, but I've separated the, let's say I have this classification for you, which is we have on one side we have evolutionary based fuzzing, in which we employ genetic algorithms in order to come up with a certain input that will try to go as far into the code. So how fuzzing actually works, if we have an application that accepts an input and do some kind of conversion and parsing of that input, then with evolutionary based fuzzing, we will be pretty much oblivious of the file format, and we will just try to come up with it along the way, so to speak. So we will use different mutation strategies in order to do that, to reach as far into the code as possible. Current state of the art is held by tools as American Fuzzy Lop, libfuzzer, and HongFuzz, something developed by Google. This comes, this is approach that is, let's say, opposed to the generational based fuzzing, in which we come up with an input for the fuzzer by respecting a certain set of rules. So we say, please don't fuzz that because this is important. For example, it's a set of magic bytes for the file format, but fuzz this and come up with an input. And the idea here is to reach further into the code because we respect those set of specification about the file format, and I don't know, reach maybe interesting further into the code in more interesting corner cases. So as the fuzzing workflow, first we will feed the test case into the application. Then you will observe the trigger path, and this is done with instrumentation. Who heard of instrumentation from here? Please raise your hand. So what instrumentation essentially does to a piece of code that is compiled with that is it will insert certain pieces of code during our project, and when that application is run, it will inform, let's say, the fuzz, actually the fuzz application that you use, of the state that you've reached, how further you've reached into the code. And this is useful because if you, the idea here is to use different mutation strategies in order to reach further into the code. Okay, so we observe the trigger path, then you modify the test case accordingly, and check if that modification allowed us to reach further into the code. If that is not the case, then we modify the mutation strategy and try something else and see what happens. So as you can see, this is a cyclic process, and the current fuzzers allow us to completely automate this. And this is also one of the reasons that I like about fuzzing, because if something I mean, if the TL looks and asks me what I'm done, I can say I'm not slacking off, my application is fuzzing. So as we saw earlier, there are a lot of fuzzers, and I've chosen to conduct my investigation using American Fuzzy Lop, which, except of being a rabbit breed, is a fuzzer developed by Michael Zalewski, which is a Google security researcher. He came up with this amazing tool that employs genetic algorithms in order to do fuzzing, so it's genetic based pretty much. What I like about AFL is that it's very easy to set up. It has a very good handling of crashes and hangs of the application, and of course, last but not the least, it has a huge trophy case of found vulnerabilities. I mean, in OpenSSL, ImageMagick, you name it, if you go to the page, you can find a lot of vulnerabilities, and those are just the only that were reported back to Michael Zalewski, and he updated the page, but there are a whole lot more. I mean, I look a lot at different projects and their bug pages, and a lot of them are found using AFL, so it's a very much employed tool. Now we have the fuzzer. The next thing is to choose an application that we want to fuzz, and I've stumbled upon during my searches on SDL. Another thing that is very hard for fuzzing is to find something that wasn't fuzzed before. So if you start, so those from this room that did fuzzing, you feel my pain. So this is a very interesting library, because as you can see, it was employed to create games and engines and different kind of application. It was actually used for the Cry engine, which, as you might know, it was used to create the game Far Cry for those gamers that are in the room. Also, it has a lot of functionality. You can even handle sockets with this library, so a lot of functionality equals for security researchers, a lot of things that could go wrong. Let's do that. Okay, now we have the fuzzer, we have the application. Let's go and start to do the preps for the actual fuzzing campaign. The first thing that you do, you download the sources of the application that you want to fuzz, and you compile them with the AFL wrappers for GCC. So what this actually does, except for the compiling part, it adds that layer of instrumentation that we talked about earlier, which will inform the AFL process where exactly you go with that input that you serve. Another thing that we do is we compile the sources using this flag, fsanitize equal address. What this does is effectively allows you to compile the sources using address sanitizer, which is a memory, which is a tool for C projects that allows you to find memory-related issues, which those juicy ones that the security researchers love, as for example use after free heap based buffer overflows and so on. So why the white paper of the other sanitizer states that during their tests they saw that adding this layer, the supplementary layer of instrumentation, makes the application runs 2 times slower. But we want to do that because we want to find also this kind of corner cases. Now, after we successfully compile, actually that's another pain that those who want to do fuzzing experience. It's pretty much, it's sometimes very hard to not create a conflict when you're using the AFL wrappers and also the other sanitizer. But we successfully did that. Now we're trying to make a test harness. So what is a test harness? Is essentially a piece of code that we write in order to fuzz the library indirectly. So what we're doing here, what we're trying to do here is we're trying to fuzz a call to that library. And the test harness is pretty straightforward. We initialize the SDL environment, then we make the call to the function, the method that we want to fuzz within the library, and then we free the memory. We compile that also with the AFL fuzz, and okay, so we compile that. Then we go on to the actual fuzzing. This is very important if you want to do fuzzing. Remember when I said that AFL is very easy to use? Well, this is the reason. This is the check it out. You just have to specify the input where you supply the test cases, the initial test cases for the fuzzing process. Then you specify the folder where you want AFL to write the hangs, the crashes that we want. This is a flag that allows you to give unlimited memory to the child process that is going to be started during fuzzing, and that we have to use this flag because I conducted my experiments on x64 architecture, and other sanitizer consumes a lot of memory there, so this is why we have to do that. Another thing that we have to do is to just give a name to the fuzzer. This is not really important. And then we supply the path to the harness function that we compiled earlier. And we inform AFL that we are going to supply the test input as the first argument. So the famous AFL screen, sorry. This is not, I mean, can you see it clearly? Sorry about that. Okay. What is a lot of interesting and geeky stuff happens here. AFL gives you a lot of information about the fuzzing campaign, but what is really important is this thing. So you want the AFL to make to fuzz as fast as possible. Here we have only 170 executions per second, which is pretty low, pretty slow. So we wanted we want a better fuzzing speed. So you can see I put the specification on the machine that I conducted fuzzing because I want you to I want to make something clear. You don't need something like a Google level infrastructure to do fuzzing. You can just start it doing at home and take a project and see what that leads you to. So what we can do to make the rabbit run faster? First thing that we can do is to enable the AFL persistent mode, and what that is AFL works like this. It gives an input, a test case to the application, then the application processes that file, and then the program closes. And what we do here is practically keep the application open and feed it input while the execution context is still on. And that will effectively allow us to spend less time in the kernel mode and hopefully increase the execution speed doing that. Another thing that we can do is to supply smaller test cases. In my case, when I've started the fuzzing attempt, I have supplied some wave files that were about 100 kilos, and I think that I thought that I could find smaller test cases. Another thing that we can do is to run the fuzzer from the RAM disk. And the idea here is to read the actual test cases from the RAM in order to, because as we know, reading from RAM is so much faster than reading from the actual disk. And last but not the least, obviously we can run multiple instances of AFL and improve the fuzzing speed linearly. Okay, so again, the new famous AFL screen. This time we have an execution speed of 420, which more than doubled, and now I'm happy with my fuzzer. After I run the five fuzzers in parallel, I get the staggering speed of 150 and 87 executions per second, which is better than 200. And this is what I meant when I said that when TL asks you if you're stacking off, you can do fuzzing. If he sees this screen, he won't interrupt you ever. For those that are curious, I have actually employed 2 mocks in order to open multiple instances on the virtual on the server that I was doing fuzzing. So it's very easy to use. I recommend it. And the results: 11 CVEs, of which I'm very proud, are my first CVEs of this year. If you're wondering what is with the C highlighted in red, that is because when I've posted the blog post, someone was very kind and pointed out that I had a spelling mistake, and so I've corrected it. So someone exploited someone that was trying to exploit anyone, another person. Okay, so I haven't found these vulnerabilities by doing just one test harness, and I'm doing multiple test harnesses. So I found the vulnerabilities in different module of the library, both in the audio and the video module. Another important thing is that the vulnerabilities were introduced by a commit that dated from 2006. So it's a lot of time from there. The library is still employed, and the last version of the library was affected by these vulnerabilities. So it took me a while to find something that wasn't fuzzed, but that happened because it was a very old library. Okay. I thought that it would be important to specify also the timeline, everything that happened. So I make you acquainted with the whole process. So in order to get the setup working, choosing a library and come with a test harness or come with a certain method to fuzz from that library took me, let's say, actually they're not a few days. I wanted to say a few weeks there to be more accurate. Then fuzzing the library, that this is why FL is awesome. It took me only 24 hours to come up with interesting crashes. There were like 60 crashes, of which then and those crashes then I started to filter out, and it turned out 11 interesting ones. And this is the next step: identify and trace the crashes. That took me a few hours. Then I have reported the vulnerabilities to the SDL bug platform, and they were. This is again very interesting. The development team was very quick with its response. It was a matter of few hours. They responded faster than Mitre, and that doesn't happen very often. Sometimes when I've reported other things to development and also to Mitre, usually the development team response was slower. So Mitre was kind enough and assigned the CVs for my interesting findings in a matter of 24 hours. And in 2 weeks, the development team fixed all the issues. So if you want to exploit them on an Android application that uses the library, say bye-bye to that. Also, I wanted to say, so you probably might wonder now, everything is nice and how can you actually exploit these vulnerabilities? One question might be. So these are 2 scenarios. They're very much similar, and they are they are connected because they both makes use of social engineering. So you came up with an application or a mod for a game that you're interested in. So you specify a malicious WAV file that uses that. So hey, check it out, my new mod for my new game. It has amazing sounds and amazing music. Someone will try to download your game and will try it out. And then when we actually parses that file, it will go to the vulnerable function, and then the exploit will do its work. That is also true for the second scenario. So by now, if you think that okay, security research and the pleasure of finding vulnerabilities is too much of an esoteric reason to do research, here is the main reason that you want to do fuzzing. The European Union, this is an article from this year, offers approximately $1 million. Those are not for one project, but for multiple projects that are of interest, are employed by a lot of people. So if you find something with fuzzing, let's say, you might get the money. So it's a bug bounty program. That was my presentation. Thank you for your attention. One more thing, sorry. If you want to go to the full article, and if you want to do fuzzing yourself, I've tried to make the blog post as much as self-explanatory as possible. I've went through the whole steps of doing so because I had troubles myself of setting up and connect every piece together. So if you also have questions, you can find me on Twitter, and we can talk further from that point on. Thank you.
Okay, so if you have any questions, where's the microphone?
Hi. Have you used libfuzzer, and if so, can you make a comparison between those two?
Okay, thank you. Very good question. Actually, yes. I was expecting that. So paranoia is a good skill when doing security research because you come prepared. Yes, I have used the libfuzzer. I've actually used it to fuzz a project which is called Chesanta Mongoose. It's an interesting piece of software because it gives you interface with a protocol that is called MQTT, which is used on IoT devices for one. And I've used it with success, and I found something, but that was already reported just in a matter of the exact stack trace, the exact method that was crashed and everything. So it was the same finding, but he was quicker than me. But that didn't affect me very much because it told me that I'm on the right track. So keep that in mind. Someone might fuzz his way into the application faster than you. A comparison, well, libfuzzer is very much is a perfect tool for, as its name implies, for libraries. So what I've done is something like that. I've used libfuzzer. I've used AFL in order to do library fuzzing, which is not very. It's not unusual thing. They're very similar. One comparison, which is the most important thing, is that they are very similar in the outcome of the fuzzing process. So, for example, if you find a crash with AFL in let's say 4 hours, libfuzzer we have similar results, and that happens because they have the same mutation engine. So they come up with test cases during using the same piece of code, and that makes them very similar. We can discuss further. This gets a little technical, but I think it's enough. So you can use it. You can use both of them, and you kind of expect the same outcome. Other question, please ask.
Okay, so nice
Hello.
talk.
Thank you very much.
I have to announce that I will be having more than one question, so sorry for holding the mic.
No problem. Go crazy.
So first of all, in the input folder, where you placed your input test cases,
Okay.
were they valid files
Yes.
or already corrupted?
Yes, they were valid files, and this is the thing that I love about mutation strategies, that will take something valid and will transform it in something bad. That's just amazing. They were valid wave sound files, and one thing that you want to do when you are employing AFL is you can supply another parameter to the fuzzing campaign, and that is called supplying supplying a dictionary. You can supply it with an X, and what that does, it will insert certain strings that are specific to the format that you're trying to fuzz. So you can insert magic bytes or something, and that will kind of help the mutation engine to come up with something that is valid and will reach further into the code, but in a faster manner. So you'd want to do that.
Okay, and the second question, what about templates of the input files? I mean, let's suppose we have a format, and the first bytes of the format maybe is a checksum. So the first things that the program, the target does is to check the checksum. So maybe we need, when fuzzing, to have a template and somehow to tell the fuzzer, look, generate the test case, and then the first 4 bytes, replace it and make it a valid checksum for the file.
Yes, this was the problem that someone came up with a while ago. And that's why you have generational based fuzzing. You have the set of specification, then you build the input file and you serve it to the application. So that is exactly the reason why they come up with tools that use this fuzzing mindset. But they are more commercial tools. I mean, they are, let's say, QA oriented, because you would want to see if the developer respected the set of specification for parsing and converting different file formats. So AFL can't do that, can do that. Okay, that was a lie. It can do that. There is a fork of AFL which was developed by one of my colleagues from Polytechnica University. It's a fork that is called AFL Smart, which does exactly that. It uses the pitch framework, which allows you to specify the format in a way, and combines that with the amazing power of the mutational strategies that AFL has. So you can do that too with AFL. Please check out the AFL Smart fork and see how that goes.
Okay, great, thank you.
Any other questions? There's still time till pizza arrives, so you have to have some questions. Okay. If there aren't any other questions, Radu, we thank you for your presentation.
Thank you.
Until the pizza arrives, when Anatol will expertly wink at me and I will abruptly stop talking, I have an announcement to make. I have mentioned this last time as well, and I will keep mentioning it up until the deadline, which fortunately for all of you is March the 15th. So on March the 15th, there will be a hard stop to any requests that you all can make to donate 2% of your income tax to any NGOs that you would like to support. That's the deadline, March the 15th. Up until that date, however, you can check out all the tech-related or social-related NGOs that operate here in Romania and pick a nice target that does exactly what you would like to do if only you had a little more time, and donate 2% of your income tax to that NGO. One such example is the Association for Technology and Internet, which Matei is part of. If you remember Matei, we had him as a guest last time. Another one, I will insert a small plug here, is Code for Romania, where I'm a volunteering developer. If you'd like to talk about it, we can meet up after this impromptu announcement. And you can find others as well. So as long as you're not a person who graduated for a technical college and working as a programmer, in which case you do not pay that income tax, you can donate 2% of your income tax, and so can your friends and spouses and family. And I highly encourage you to do that, because otherwise you can't control the destination of that little bit of money that you could donate, and the destination is probably not doing something you would like to be done in the world. Thank you.
Okay. Thank you. Okay. So to sum up this event, we'll have. I will remind you that we have the Patreon account that you can, where you can donate a monthly amount to support the pizza that should be coming to this event. Okay. Besides that, if you enjoyed today's presentation, we encourage you to open unlock your mobile phone and open this URL or scan this code and submit your feedback for today's event. It will redirect you. So what will you do? You'll replace the feedback form? Oh, evil you. Okay. Hmm? I'm not. Okay. So other than that, you can find us on Telegram. You can find us on Facebook, on Twitter as well. Keep in touch. Let's keep in touch. Let's talk. Let's keep reminding everyone that security is important. Besides that, as I told you earlier, we have the weekly meetings, JMP Coffee, where we play CTFs and we teach people about security. So if you'd like to volunteer to keep to hold a workshop, you're very welcome. Please write us. If you are, would like to learn more about that, join us and let's see. Let's meet weekly at this event. And once again, thanks Orange Fab for supporting this event. Okay, with this, I'd like to end this meetup. Let's get to networking and wait for the pizza. Thank you.